Hello guys, welcome back to my channel Algorithm Avenue. From our past few videos, we have been discussing about the various factors that help us to improve the performance of an artificial neural network. Okay, in this video, we'll be discussing one of the important factor that is feature scaling. Okay, in this video, our aim is to clearly understand what actually is feature scaling, and we'll be taking an imbalanced data set and we'll be applying a feature scaling to it and we'll be observing the results. Okay, now let's take an example to understand the feature scaling. Okay, now this is a binary classification dataset. Okay, which contains two input columns and one output column. Okay, my one of the input column is age, which generally varies from 0 to 100. Okay, generally the age of a person varies from 0 to 100. Okay, this is the salary column, which generally varies from 0 to thousands, 10,000, lakhs or crores. Okay, now when you keenly observe this data set, there is a clear cut scale difference. Okay, there is a very much clear cut scale difference. So these kind of data sets are called imbalanced data sets. Okay, now when you feed these imbalanced data sets to the neural network, various problems occur. Okay, among them, one of the problem is slower convergence. Slower convergence. Okay, in slower convergence, what actually happens is, now when you feed a balanced data set, when you draw a curve for balanced data set for loss and weights, as this is your global minimum point, the gradient descent will start generally from this point or either from this point and will slowly converge to this global minimum point. Okay, this is the case of normal data set. Okay, now when you feed an imbalanced data set, the gradient descent will move in this zigzag manner. Okay, it will move in this zigzag manner. So due to this zigzag movement, the convergence will be very much slow. Okay, this is the first problem that we face due to imbalanced data set. Now the second problem is gradient instability. Gradient instability. When it comes to gradient instability, we face two problems over here, that is vanishing gradient problem and exploding gradient problem. I have discussed about this both the topics in my past few videos. Okay, please check out those videos. Okay, one of the problem, that is third problem, is lack of generalization. Generalization. Okay, in lack of generalization problem, what actually happens is, your model performs well on the training data but completely fails on the test data. Okay, your model performs exceptionally well on the training data but completely fails on the test data. Okay, now what we'll be doing in the next section of the video is, we'll be taking an imbalanced data set and we'll be feeding into a neural network and we'll see how these three problems are occurred. Okay,
Now we'll be taking an imbalanced dataset and we'll be feeding to our artificial neural network. Okay. For that, I have imported my necessary libraries and this is my dataset I have considered. Okay. My dataset is in zip file, so I have done unzip. Okay. Now this is my final dataset. Okay. It contains around 4 columns. Okay. 4 input columns which contains user ID, gender, age and estimated salary. Okay. For our problem statement, we don't require this gender and user ID column, so I have removed that 2 columns and this is my final data frame. Okay, it contains age and estimated salary as input columns and purchased as output column. Okay, now finally I have plotted the dataset. Okay, when I plotted the dataset, these are my data points and the age is ranging from 20 to 60, whereas the salary is ranging from 20,000 to 1,40,000. Okay, now I have done the type conversion from data frame to numpy and from numpys to tensors. Okay, in this both the cells I have done those operations. Now I have split the data into training and testing. Okay, 80% of the data I have given to training and whereas 20% of the data I have given to testing. Okay, here I have built my model. Okay, my model contains 2 layers with one hidden layer and one output layer. It contains around 128 hidden units. Okay, I have selected binary cross entropy loss function. Okay, sorry, the reason behind this is my problem is an binary classification problem, so I have selected binary cross entropy problem. Okay, sorry, loss function. Okay, my optimizer is Adam optimizer with learning rate 0.001. Okay, this is my accuracy function. Okay, now I'm training my dataset for 100 epochs. Sorry, I'm training my model for 100 epochs. Okay, from here to here it's my training loop and this is my testing loop. Okay, this entire thing is my testing loop. Okay, here I'm printing my model results. Now when you keenly observe my model results, the training accuracy has started from 34 and test accuracy started from 40. Okay, now when I scroll down at the 100th epoch, okay, yeah, at the 100th epoch I've got around 65% training accuracy and my test accuracy is around 40%. Okay, you see that we have got very low training accuracies and as well as test accuracies. Now in the next section of the video we'll be finding the exact reason behind this.
In our previous section of the video, we have taken an imbalanced dataset and we have fed to our artificial neural network. And we have also observed the results where our training accuracy is very much low as well as test accuracy is also very much low. Okay. Now, in this section of the video, we'll be finding out the exact reason behind this. Okay. The exact reason behind this is improper assigning of the weights. Okay. Improper assigning of the weights. Okay. Now, let's discuss what actually does it mean. Okay, now we have age column. The age column is of low scales. Okay, we have lower numerical values. Due to presence of this lower numerical values, our neural network basically gives less priority to this age column. Okay, due to presence of lower scales in the age column, our neural network or artificial neural network basically gives less priority, that is less importance to our age column. Due to giving of this less importance to our age column, the weights assigned to this age column will be very much low. Weights assigned are very much low. Okay, the weights assigned to each column are very much low. Now when it comes to salary column, the scales are very much high. Okay, due to this difference in scales, okay, due to higher scales, what actually happens is neural network thinks it has an important feature and gives higher priority. Salary is given higher priority. Due to higher priority or importance, weights assigned to the salary column are very much high. Okay, the weights assigned to the age column are very much low, whereas the weights assigned to the salary column are very much high. Okay, due to imbalance assignment of this weights, okay, due to very much drastic change in the weights, there will be various problems occur. Okay, we have already seen in the previous section of the video. Okay, this is the basic reason behind the low training and test accuracy. Okay, now we have found the exact problem. Okay, now we'll be seeing the contour plot when we feed the balanced dataset as well as imbalanced dataset to our artificial neural network. Okay, this is basically the contour plot for balanced dataset and unbalanced dataset. Okay, this is for the balanced dataset and this is for the unbalanced dataset. Now when you feed the balanced dataset to your artificial neural network, the contour plot will be basically this way. Okay, as this is our global memo point, our contour plot will be very smoother convergence. Okay, now when you feed an unbalanced data set, the contour plot will be in this way. Okay, very noisy convergence. Okay, this is because of slower convergence. Okay, this is basically the slower convergence, and here when it comes to balanced data set, it is faster convergence. Okay, now what we will be doing is we'll be finding a finite solution to this problem. Okay, the finite solutions to this problem are standardization and normalization. Okay, these are the two feature scaling techniques. One is standardization and other is normalization. Okay, in standardization, what you basically do is you select a column. Okay, you select each column of your data set and calculate the mean and standard deviation for that particular column. Okay, now when it comes to age, you take the age column, you calculate the mean, standard deviation, and what you will be doing is you will be selecting each data point separating them. Okay, you would find the difference, you subtract the mean. Okay, you subtract the mean from the data point, you subtract the mean from the data point and divide with the standard deviation. Okay, this is basically what you do in standardization. Okay, in standardization, after applying the standardization, after basically applying the standardization, the data points are mean centered. Okay, the data points are mean centered. Okay, in standardization, the mean is equal to 0 and standard deviation is equal to 1. In standardization, the mean is equal to 0 and standard deviation is equal to 1. So the data points will be mean centered. Okay, they will be mean centered. Each data point will be mean centered. That is, they revolve around the origin. They revolve around the origin with standard deviation 1. Okay, with standard deviation 1. So the scales of the each data point will be from -1 to +1. Okay, basically in standardization, the scale of each data point will be from -1 to +1. Okay, either it may be in minus, okay, either it may be in the range of -1 to 0 or 0 to +1. Okay, this is basically what happens in standardization. Now we'll be looking at normalization. Okay, in normalization, what you do is you select a column. Okay, you select a column and you select the minimum value and maximum value of that column. Okay, you basically extract minimum value and maximum value of that column, and you subtract minimum value from a particular data point and divide it with maximum value minus minimum value. Okay, what you actually do is you extract minimum value and maximum value of that particular column, and you'll be subtracting from the each data point the minimum value and dividing with max minus minimum of that particular column. Okay, this is basically what happens in normalization. Okay, after normalization, the data points will be from 0 to 1. Okay, they basically will be from 0 to 1. Okay, the data points will be from 0 to 1. Okay, in this way our data points will be spread from 0 to 1. Okay, this is basically what happens in normalization. Now you may have a doubt that when do I go with standardization or normalization. Okay, now in our case, okay, now let's come to our case where we don't know the minimum value and maximum value of our dataset. Generally in salaries we cannot determine the minimum value or maximum value, so we go with standardization. Okay, generally in datasets like where you know the cgpa will be from 0 to 10. The minimum value is 0 and maximum value is 10. So in that kind of scenarios you go with normalization. Okay, this is basically the difference between standardization and normalization. Okay, there are other various factors that has to be considered for selection of this standardization and normalization, but for now remember that where you know the maximum value and minimum value, you select the normalization. If you don't know the maximum value or minimum value, go with standardization. Okay, now in the next section of the video we'll be applying the standardization to our data set. Okay, to our data set, and we'll be feeding to our neural network and we'll be observing the results.
In my previous section of the video, I have discussed that we need to apply standardization to our dataset. So now I am applying standardization to my dataset. Okay, for that, from Scikit-Learn.Preprocessing, it provides a class called standard scaler. Okay, to apply standardization, it provides a class called standard scaler. Okay, I am storing that standard scaler class in scalar. Okay, in scalar variable. And what I am doing is I am creating a new variable. Okay, new variable that is xtrain scale, and I am fitting that. Okay, I am fitting that xtrain. Okay, I am fitting that xtrain to the standard scalar class. Okay, in training for training data you generally fit, and for test data you directly transform. Okay, the reason behind this is in training data what happens is when you fit the standard scaler for the training data, it already calculates the mean and standard deviation for the training data, and when it comes to test data it again doesn't calculate the mean and standard deviation, but it directly applies the same mean and standard deviation for the test data as well. So that is why we are doing the fit transform in case of xtrain, okay, for the training data, and we are doing just normal transform for the test data. Okay, these are my finally scaled data. Okay, this is my age column. Okay, sorry, this is my age column and this is my salary column. Okay, I have got my scale data over here. Okay, this is entire my scale data. Yeah, Now I'll be scrolling down, and when I plot the data, okay, when I plot the data, you can see that there is a huge difference in the scales. Okay, my age column is generally from -2 to +2, and my salary column is from -1.5 to 2.5. Okay, you can clearly observe the difference in, you can clearly observe that the data is scaled. Okay, the data is scaled for this data set. Okay, now I am applying scaled data set to my model. Okay, here I am applying scaled data set to my model, and I am running it for 100 epochs. Okay, this is entire my training loop, and this is my testing loop, and these are my model results. Okay, you see that initially I have got around 30% test training accuracy and around 36% test accuracy. Now when I scroll down to my 100th epoch, you can see that the accuracy has drastically improved. Okay, you see that there is 89% of the training accuracy and around 87% of the test accuracy, whereas in our previous case, let me scroll up. Okay, in our previous case we have got around 65% training accuracy and 40% test accuracy. Okay, we have clearly solved the problem of unstable training. Okay, you see that there is a clear-cut stable training, and we have got around 89% training accuracy and 87% test accuracy. Means our model is able to generalize well. Okay, this is the advantage of scaling the data. Okay, in future if you receive any data set, first apply standard scaling. Okay, apply feature scaling to the data set as a pre-processing step. Okay, apply scaling as a pre-processing step, because due to scaling there will be no harm in the model training. Okay, this is basically the entire video of feature scaling. Okay, hope you like this video. If you like the video, please like, share and subscribe. Thank you.